Hello and welcome back to your YouTube channel. I'm Ziba and I'm here with another exciting episode of Math Mastery. Today we're diving into the fascinating world of logarithm and exponentials. Don't worry and do not be intimidated by these words right now. You can watch my previous videos on the basics of logarithm and exponential and the properties, the rules, and some basic simple question on these two topics. Today, by the end of this video, we will be solving more examples, more advanced ones like a math wizard. But before we jump into the content, make sure you hit that subscriber button and ring the notification bell so you never miss out on another episode. Now let's get started. So logarithm and exponential, okay, they might seem complex, but they're essential tools in mathematics. They also solve problems involving growth, decay, and many real-world applications. Today, we will break down the concept, explore some examples, and tackle a few sample questions that you might encounter in your final exam. So grab your notebook and let's embark on this mathematical journey together. Okay, let's begin with some concepts. Okay, so as you know, logarithm is the inverse operation of exponents. Okay, so if you have a equals b to the power x, which is the exponential format, you can change it. The equivalent of the logarithm form would be logarithm of a to the base b equals x. Okay. Okay, let me introduce here with more details, introduce you with the terminology. So the b here is the base, the x is the exponent, and the a is actually the argument. So we have another a here. Okay, there are some conditions about the values. I want you to refer back to my videos and see the rules which apply to logarithm and exponent. But in this video, I will be focused on doing more examples, practice questions to prepare you for the final exam. So let's start with a simple one. If 2 to the power 4 is equal to 16, right? This is the exponential form. The equivalent logarithm form would be logarithm. Okay, so as per this formula, the base is 2, okay? 4 comes here, and this is 16, okay? So remember, guys, this is a very simple question because you already know what is 2 to the power 4, and you can simply see how the relationship between these two works. But let's explore more advanced questions, including the equations and graphing. Okay, so let's start with the very basic one. Let's say 3 to the power 2x is equal to 9. So here we have, on one side we have an exponent, on the other side we have a number, but there is a relationship between these two. Let's say for one of them, if you encounter such a problem, the base can be converted to one another. So let's say for 9, I can just write it as 3 to the power 2. So when the two bases are the same, it's 3 and 3, you could say that 2 is equal to 2x. So from here, you could say that x is equal to 1. Another type of question would be, let's say, 2 to the power 3x minus 4 would be 1/8. And then here, you would have x plus 1. Okay, so this is exactly the same as the previous one, but here you have to expand on the rules. So here 1/8, okay, I put it down here, is 8 to the power negative 1, so which is 2 to the power negative 3, okay? So here, what I can do, I could say 2 to the power 3x minus 4 is equal to 2 times negative 3 times x plus 1. The bases are equal, so from here I can say that 3x minus 4 is equal to negative 3x minus 3. Okay, so from here I could say 6x is equal to negative 3 plus 4 is plus 1. So x is 1 over 6. Okay, these are some very simple ones, but there are more advanced ones that you have to use your knowledge, of the rules of exponents to be able to actually answer the questions. Okay, let's do another question, which is a little bit even more advanced than the second one. So here, let's say you have 4 to the power 6x, you have 2, you have 64. What I suggest here, it's up to you, but take a look at on this side, you have 39, which you cannot convert it to either 2, 4, or 6. So probably you have to come up with something here, a common base here, and then use factorization. So let's see, 4 to the power 3, it's actually 64, okay? So 4 to the power 6 would be 63 to the power 4, and 4 to the power 6x would be 62 to the power 2x, okay? So from here, I simply substitute 2 times 64 to the power 2x. Instead of 4 to the power 6x, I put 64 to the power 2x plus 64, and then I have here 64, okay, to the power 2x, and this negative one is actually dividing by 64, right? Okay, so from here it would be equal to 39. Let's do some simplification. So this and this will cancel out. What I can do here, I can, let's say 64 to the power 2x can be factorized. Then I would have 2 plus 1 equals to 39. Okay, so from here, you can divide both sides by 3, right? So on this side, you would have 64 to the power 2x is equal to 13. This is an exponent. You can, in order to find the value, you can just simply change it into logarithm, okay? So logarithm of 64 comes here because it's the base to the power 2x, and 13 goes here. So from here, you can simply say that x is equal 1 over 2 logarithm of 13 to the base 64. And then for this one, you can just put it in the calculator and find the answer. Okay, so in order to calculate this value, log of 13 to the base 64, you cannot do it in your calculator in one go. So what you can do, you can go log 13 to the base 10 divided by log 64 to the base 10. You calculate this value and it comes up with 0.616, and then you multiply it by half. So the final answer is 0.308. Okay, let's continue with another example. Here again, we have exponents. What you can do here, let's say on this one side, you can factorize 2 to the power x. So you will have 2 to the power 3 here plus 2 to the power 4. And then on this side, you will have 96. This is 8. This is 16. So that would be 24. So let's divide both sides by 24. So here you would have 2 to the power 2x equals to 4, which is 2 to the power 2. From here, you could say that x is equal to 1. For the next one, here you have the base as 5. And as you know, 125 can be written as 5 to the power 3. Square root of 5 can be written as 5 to the power 1 over 2. So let's substitute 5 to the power x is equal 5 to the power 3 multiplied by 5 to the power half. So 5 to the power x is equal to 5 to the power 3.5, right? 3 plus half. So from here, you could say that x is 3.5. Moving on to the next equation, here you have logarithm of x minus logarithm. These are logarithm. From now on, we will focus on logarithm equations. So again, you have to refer to my previous video to see the list of properties of logarithm. Here, as you can see, the bases are 3. So when we have a logarithm subtracted from another one, as per the properties, that would be x divided by 2 to the common base equals to log 7, 3. So here, what you can see, both of them are log, the bases are the same, so that means x over 2 is equal to 7. In other words, x is equal to 14. That's an easy one, but take a look at the other one. Here, again, what you can see here on this side, you have log plus another log, and the bases are the same, so you have log, base is 2, but here, what you have to do is you have to multiply them, right? And then to this side you have 3. So you cannot solve this logarithm. You have to change it into exponent form and then go from there. So if I want to change it to the exponent form, that would be 8. It's equal to x multiplied by x plus 2, or 8 is equal to x2 plus 2x. Okay, this is definitely a quadratic equation. So you have to go x2 plus 2x minus 8 is equal to 0. I prefer to solve it from factorization. X plus 4 and x minus 2. If I add them, I get 2. If I actually multiply them, I get 8. So if these two are multiplied together and the answer is 0, that means any of these two brackets can be a potential answer. So one answer would be negative 4 and another answer would be positive 2. But we are not done yet. We have to go back and substitute it here and see if the two answers are actually applicable. So if I put negative here, that would be negative 4, and this one would be negative 2. But if I multiply them, it would be 8. So that one is good. But how about 2? Even 2 is a good answer. So both of them are accepted. Another important type of question that you will definitely encounter in a final exam would be about exponential growth or detail. So they usually give you an kind of exponential equation. Let's say f of t, it's equal to 200 e to the power, let's say 0.02t. Okay. And then they tell you that, let's say this is an example, this is the equation of the population of a specific kind of bacteria, and the population grows according to this formula. Okay, where T, okay, this is very important. So T, which is also seen here, is measured in minutes. Okay, so measured in minutes. Okay, remember. And how many bacteria are present? Then they ask you a question. So let's say here they will ask you, let's say, how many bacteria are present after 5 minutes? Okay, so the T is 5 minutes. What we have to do, because the T, it's already mentioned that it is in terms of minutes, so T is 5. We will just substitute it. F of 5 would be 200 e to the power. This will be multiplied by 5. So that would be T is 5, right? So then you put it in your calculator and you see the answer. Okay, now the T is 5, so f of 5 is 200 e multiplied by 0.02 times 5, and then e to the power, which comes up to e to the power 0.1. I put it in the calculator, I find the value. The final answer would be 54. So the number of bacteria after 5 minutes would be equal to 54. Let's say the second part of the question is asking you what is the number of bacteria Okay, this time they ask you after 5 hours. It's not minutes, but it is hours. So what you have to do, first of all, you have to change it in minutes, which is 300. Then you just substitute a t as 300. And when you substitute it as 300, here your answer would be 200 then 0.02 300, which if you put it in your calculator it would be approximately 80,686. Remember, guys, when you're talking about numbers and population, you have to always round it up. So there are these number of bacteria. So this is number of bacteria after how many hours? After 5 hours. Number of bacteria after 5 hour, or let's say 300 minutes. Okay. So if they ask you to find the number of bacteria after a typical number of hours or minutes, you simply, what you do, you simply substitute. But there is another type of question. So they will ask you, let's say, when does the population reach a specific number of bacteria? So here they ask you in in the third part of the question, they ask you about the T. They give you the population, okay? So they say that at some point, okay, at some point in T, the population reaches how much? Let's say 100,000 bacteria, right? 100,000 bacteria. And then they ask you, when is that time? So what you have to do here, you have to act opposite. So you say that the population in 100,000, right? So 200, and then here you would have e to the power 0.02, and then t is missing. So here let's um, do some simplification. So 1000 divided by 2 would be 500. Then you have e to the power 0.2. From here, if you want to solve it, the best thing, your best bet would be changing it into logarithm or ln. So you take ln of both sides, which would be ln 500. It's equal to 0.02 t. Sorry. So this is your, if you take ln, this is what you will get. And the final answer would be ln 500, right? Divided by 0.02, and then the answer would be around 310.73 minutes. Okay, remember the unit of time was minute. So here, what you have to do, you have to do exactly the opposite. So they give you the population and they ask you to find the time in which that a specific event occurred. Let's do another example similar to this one. And remember, guys, these type of questions are either exponential growth or exponential decay. The only difference is that when it's growth, it's increasing in time. When it's decay, it's decreasing in time. Okay, here we have another type of bacteria in which the population growth, it's given in terms of time as 500 times e to the power 0.05 t. Okay, so again, t is measured in minutes. Let's say it doesn't necessarily need to be minutes. It could be seconds, it could be hours, it could be days, it could be anything. But then here it's given in minutes and they want you to find the population after 4 hours. Okay, so t is in minutes. We have to convert 4 hours into minutes. So 4 hours into minutes would be 4 times 60, which is 240 minutes, right? So now what I have to do basically is just find the f of 240, which is 500 e 0.05 times 240. So if you calculate the final answer, it will be 81,377. So 81,377 bacteria after how many minutes? After 240 or after 240 minutes. Okay, this is the answer. But we're not done yet. So they ask you, this time they ask you at what time, so T is missing, the population reaches 100 million. Okay, so at what time the population reaches 100 million? So f of t is 100 million, and we know that it should be, we are trying to find the t, so here it should be equal to 500, e is equal 0.5 t. Now I have to do some simplification. These two zero can be simplified with this thing. Now let's do one. We have 1 million divided by 5, which is 100,000. It's equal to e to the power 0.005 times t. Here you can take ln from both sides. Okay, it's very similar. It's actually exactly the same solution, different numbers. So this would be 0.5. You divide both sides by 0.005, and then the final answer after simplification, it will come up to 244 and 12 minutes. Okay, so just to give you a recap, right? So this is extremely easy. First, so just to give you a recap, it's extremely easy. First, they give you an equation and they tell you the unit of t or x. T is usually a symbol for time, and they tell you the unit, and they ask you after, let's say, some time, what is the change that you observe, which in this case is usually number of growth or new population. You just plug it in and you find a new value. And in the second part of the question, they tell you that the population is this thing. Now, how much time has passed? And then you simply have the value of f of t. Okay, you simply substitute it, and then you have to either take log or ln. When we're dealing with e, we prefer to take ln instead of log. So you use that one, you go the reverse, and you find the t. I hope this video helps you to succeed in your final. I'll see you soon in other videos. Take care.